So hello everyone. So in this recording I will talk about the conservation of energy. So I will not show the derivation because it will take a lot of time, but the shortly conservation of energy says that energy at the beginning, the total energy actually, will be same as the total energy at end. Okay, and then in that case we can write it as the so here so we will not consider, so let me add it, the frictional forces. Okay, so the energy at the beginning, it can be the kinetic energy, it can be the potential energy due to gravity, it can be potential energy due to spring. That will be equal to kinetic energy at 2 and potential energy due to gravity and then potential energy due to spring. Okay, this is the conservation of energy. But so you can derive the work energy principle from this equation. Okay. Very simply, you can derive the work energy principle. So if you can derive the work energy principle from this one, so what it means is that, so we can say that, so work energy principle, so that if you remember, the work energy principle was the net work acting on the body is equal to the change of kinetic energy. Okay, is another form of conservation of energy. Okay, so then, but when we say conservation of energy in the book, we go with this one. Okay. But then work energy principle, if you remember this equation, it's another form of conservation of energy. So that is the, okay, so let me add these remarks here. So you can, so you can solve the problem by conservation of energy or work energy principle because they are the same principle. So you can solve both ways. Any problem, it doesn't matter. So there's no way that you can say, okay, this is only by conservation of energy, this is only by work energy principle. No, both the methods you can use. The second thing is that the advantage of the conservation of energy, the advantage here is that, so you don't need to worry about the signs. So if you remember, we said that the work is an F into dr. Okay, so here you care about sign. Are they in the same direction or not? Okay. But in conservation of energy, you don't. That is the advantage of the conservation of energy that you can use to solve the problems. Okay, and then the third thing is that, so then if there is no frictional effect, then better to use this conservation of energy. Frictional effects, it can be the kinetic friction coefficient, static friction coefficient, the drag force, whatever. Yes, better to use the conservation of energy. That is the advantage of the conservation of energy. But as I told, this is the work energy principle is the manifestation of the conservation of energy, and you can easily derive, you can easily move from this equation to the other equation. Very easily you can move it. But I don't, let me see if I can show one simple case for you. So let me show you the simplest case. Yes, simplest case that shows that we can derive the work energy principle from conservation of energy. So then no spring forces. So then it will be that the kinetic energy at 1 plus potential energy at 1 will be kinetic energy at 2 plus potential energy at 2. So I can write this one as the potential energy at 1 minus potential energy at 2. That will be the change of kinetic energy. And this one is just an mg, then y1 minus y2. Okay? Or that is then mg y2 minus y1 and with a negative sign. That's the kinetic energy. Okay, this is the work energy principle. Okay, the left hand side is the work by gravity force. That's the work by gravity. And then right hand side is the change of kinetic energy. So why do we have negative sign here? Let me add it here as well. And say that this is the ground. And then we have an object that falls to the ground. And the object has a mass of 5 kg. Okay. And then if I take the coordinate as y here, and then this will be my x coordinate. Okay. And then I know that work by gravity will be equal to the weight of the body with the distance, ds, dot product. Okay. And then I know that weight is this way, ds is that way. So they are in opposite directions. And theta is 180, and therefore the work by gravity will be WDS. Actually, this is small work. So integrate. And then, if you integrate it from 1 to 2, so that will be equal to that mg s2 minus s1. Okay. Sorry, there will be a negative sign here. Let me add the negative sign here so things. So Wy gravity will be negative. Okay. Then that will be the negative, then mg s2 minus s1. S2 is the position here, which is y2. And s1, which is position there, which is y1. You can see that the work energy principle is not something very, is not something new. It is just the conservation of energy in the work case. It's not anything that is different. Okay, with this one I stop the recording and we will solve a problem on conservation of energy.